thought I'd done this video earlier and only found out that my mic was on mute. The entire time I did the whole video, I was about to upload it to YouTube. So I'm redoing this, and it actually is just a couple hours before we meet live. So I'm doing this because I know that sometimes students won't ask questions when I have the recording going on our live session. And I want to make sure this is available on YouTube for those who don't make it. Okie dokie, and I do have this content that we're going to cover today already on YouTube. It may be slightly different examples, but it is still the same definitions. Okay, so let's go ahead and get going. So we're going to talk about circles, and we're going to keep it fairly straightly, pretty darn basic. So a circle is just basically a set of all points that is equidistant from a central point. And this central point, the measure between the central point and all the points is called the radius. We have a lot more segments that we deal with on this, like for instance, and we're again, because of our limited time, and we lost a few weeks and we're accelerated block, we're not covering everything in detail like we normally would. So a circle is comprised of, well, we can have a lot of elements to a circle. For instance, you're probably familiar with a diameter, which is a special type of chord, a segment whose endpoints are on the circle that passes through the center of the circle. This is called circle K. Okay? We name our circles by the central point. So this is circle K. Our radii, our radius, is nothing more than a segment whose endpoints on the center of the circle and on the circle. So this is a radius, this is a radius, and this is a radius. They're all equal in length, of course. A chord is just simply a segment whose endpoints are on the circle. So again, the diameter is a special type of chord. And then we have something that you may or may not be familiar with called a tangent. And this JE is a tangent. It is a segment or a line that touches the circle at exactly one point. This has huge importance in mathematics. Tangents are incredibly important. We have a secant, which is a segment or a line that consists of points on the exterior and interior of the circle, so it intersects it twice. Remember, tangent intersects it once, a secant intersects it twice. And those are the basic things that we're going to play with on mainly Wednesday's video, actually. So let's get going. I want to revisit circumference and area real fast. From middle school, you may remember that circumference is nothing more than 2 pi r, or pi d, since 2 r's make up a d, and area is just pi r squared. So what we really need is an r. Circles and squares have these really cool relationships, but we can inscribe a circle inside a square. That means that this side and this side are actually tangent. So the r forms a right angle right here, by the way, is nothing more than half the side of the length of the square, which is 5. So we have our r. So to find circumference, that's just 2 pi times 5, which is 10 pi. Okay? And that's in millimeters. And you don't go to Lowe's and say, I need 10 millimeters of rope or whatever, or string. It wouldn't actually be very much of anything. You would put that into a calculator and get 31.4. Area is pi r squared. So you're going to put that in the calculator, pi times 5 squared, and goes your r, which is 25 pi millimeters squared, which is about, I already did it down here, 78.5, okay, millimeters squared. Okay, that's just a quick area. Now in high school, sometimes we mix it up a little bit. Here we have a 30, 60, 90 triangle, and if you remember from your template, your formula, opposite your 30 is your a, opposite 60 is a root 3, and opposite your 90 is 2a. So what we do here is we need to find this diameter, which is the hypotenuse of the triangle, and that goes into even more. That's very much related to law of sine. You're going to learn law of sines and some other things in the future. So what we have here is opposite my 30 is 9 root 3. So opposite my 60 is 9 root 3. So you just do a root 3 is equal to 9 root 3. And when you solve that, you have a is equal to 9. So this is 9. And this thing is 2a, so that's going to be 18. So your diameter is 18, your r is 9. So in goes 2 pi r, which is equal to 18 pi units. Okay? Pi r squared, you put in that, pi times 9 squared is just 81 pi units squared. That's it. Okay, moving on. So I want to run through some of these definitions real quick, even though you don't have, your homework is going to be incredibly light on this. Again, we're basically taking a 2-week unit and turn it into 2 days. So what we have is the center, and this is circle C, and we have a angle whose sides are radii. This is a radius and this is a radius. This creates a central angle. This central angle is equal to the subtended arc of AB. So that's a very important definition. This is 20 degrees. The measure of arc AB is equal to 20 degrees. And this would be a minor arc because it's less than 180 degrees. A major arc would be between 180 and 360 degrees. So I can have a circle down here. Let me do a central angle of a really big one. So I'm doing this angle right here. This is bigger than 180 degrees. This would be a major arc. And a semicircle, of course, would be a diameter of 180 degrees. Right? I have this written out right here on how to name them. And again, we're going a little bit quick. And your homework, I think, I just briefly looked at it, and it doesn't really hit this too much. So minor arc is typically, well, it's almost always written with 2 letters. All right. And this is arc AB, and it's written like this right here, or you could do BA. And this is basically your starting point, and this is your direction. A major arc, because it's bigger than 180 degrees, we need a starting point, a direction, and an end point. Because if I said arc AB and you didn't know if I was talking about, you didn't know the difference between major and minor, you wouldn't know if you're talking about this going all the way around or this way. So we have to have A, D, B as our major arc. And the same will hold true for a diameter, because if I said arc PQ, you don't know if I'm talking about the top half or the bottom half. So the top half is arc PSQ and the bottom half is PXQ. All right. So let's go ahead and get this going. So moving on. Some of the measure of the arcs is 360 degrees. Some of the central angles is 360 degrees. So let's do that with a couple examples. Here's 110. The whole circle is 360. So if this is 110, this is definitely more than 360 minus 110, which is 250 degrees. All right. So what we can do is PCM. PCM is my central arc. That's given at 110 degrees. Arc PM, which is minor arc, is also 110 degrees. PNM is the major arc at 250 degrees. What kind of arc is PM? That's a minor. And this, of course, would have been a major. So when I give you problems like this, what you want to do is you want to fill out the circle first and then ignore this stuff over here. Ignore it for now. So this is going to be 18 degrees here. And JES is 90. Well, if that's 90 and this is a diameter, and that's a radius, this has to be, of course, supplementary. 90 and 90. So these are both right angles. So if this is 18 and this is 180, you're going to subtract that and you're going to get 162. So this is 162. Okay? This is 18, 90, and 90. So now you come back over here and start filling everything. You got 18 degrees for this. JA, this minor arc right here is 162 degrees. And JAS, we went all the way around, is 270 degrees. Okay? So moving on. I had this one pre-filled out. I just didn't bother erasing because of time considerations. So when you're given things, again, fill out the circle. You put this and this into your circle. Use your diameters. And this is 180, so you subtract these two from 180. This is a vertical angle, so these are equal. And then this is a diameter, so you subtract 38 from 180 to get 142. And then you go and fill all this in. Okie dokie. So I'm going to do part 2 in a separate video.